Right, so welcome back to part 2 of our operating system development tutorials. In this part, we're going to be doing something a little bit more useful. We're going to be printing a hello world to the screen. We'll be doing it in assembly, of course, so if you have a good knowledge of assembly, that's really going to help. But what we're doing is quite simple, so even if you've never done any assembly before, you should be able to follow along just fine. Right, so the first thing we need to do is we need to move a value into the A register. So we'll do that, move AH, so we want to move a value into the high part of the A register. So we want to move O hexadecimal OE. What this does is signifies to the BIOS that we are in a scrolling teletype BIOS routine, so that when we call an interrupt, which we can get into interrupts in a second, the BIOS will know to print, for example, what's in the lower part of the A register, for example H, to the screen. So then we call our interrupt 0x10, which is the code for the BIOS to print. It will print H to the screen. Now, simply put, an interrupt is just when you call this, the CPU stops what it's doing and goes on to some other routine. In this case, it prints this to the screen and then returns to where it was. First things first, we need to move this to the bottom so that we can actually reach this bit of code. So, we're moving 0E into the upper part of the A register, then we're moving the char value of H into the lower part of the A register, then we're calling an interrupt to signify to the BIOS that we want to print this value, and then we enter our infinite loop. Let's compile that and see if it works. Here we go, so we have H successfully printed to the screen. So if we go ahead and expand this, we can expand it all the way and eventually have it print hello world to the screen. So let's do that right now. We'll just copy and paste this many times. RLD. Alright, now let's compile that and reap our reward. We have now created a hello world application in a bootloader. Yay! Now, you might be thinking, I don't want to have to do all this every time I want to print a string of characters to the screen. Well, my dear friend, let's move on to the next part. We'll take our application back down to the bare bones minimum, just the jump, and we'll define a label called print string. Right, and then what we want to do is call print string. So the application will start and it'll call print string, so the compiler will know to make it call the address of wherever print string is, and then we'll type ret, which is return, so it'll go bounce to there and then it'll bounce back. Right, so we have a print string, essentially a function. So what we also need is a string for us to print, a string of characters. So let's call it test string, and then declare bytes, and then a whatever this is called, apostrophe, and let's just say this is a test string. Right, that's all fine and dandy. We have our characters in our program, but one thing we have to do is we need to null terminate this string so that we know when to stop printing characters, or else if there's stuff after this, our program will just keep reading through, it'll start reading all the instructions, it'll start reading all the garbage, and we don't want that, so we just do a comma 0, which is pretty simple. Before we move on, we need to move this stuff down to the bottom so that our extra program doesn't actually get compiled past this bit. This bit needs to be at the very end. Now what we need to do before we can go on and start actually jump to this is we need to define the stack pointer. The stack is basically just an area of memory that the program can use to store variables and data just easily and simple. And when you actually call a label like this, it actually stores the address of where it was before you did the call, so that when it gets to this return it can jump back. So we need to set up the stack. Now to set the base of the stack, we need to move a value into the BP register. So we can set 0x7c00. This value is significant because this is the value that our program gets loaded into when we actually load our bootloader. So the BIOS will put all of this program into memory address 7c00. So we'll just put our stack underneath it, and we'll put our move sp, which is the stack pointer, which is the current memory address that the stack pointer is pointing to. So that's how it keeps track of what variable it's up to. And we'll move that to BP as well. Now let's get on to actually building our function. So our function needs to know which string to print. So before we call print string, we can move into the B register. This is important because B can be used as an index, so we can actually get the value at a pointer. So we move into bx test string, which what that'll actually do is it won't move test string into bx, it'll move the address of our label into bx, so that when we go to our function, it'll point to this data. Just as a test, let's display the first value of our test string. So we'll do what we did before. We'll move a h, and we'll use the magic value, which is 0e, and then we'll move the lower part of a bx. So we'll put these brackets so we know to use this as an index, so we'll get the value at bx instead of actually just putting bx in, and then we'll call the interrupt, so int 0x10. Alright, let's compile that and see if it works. If everything goes to plan, it should print a t. So just here, I forgot to put a comma there. That's why it's important to have a pause in our batch file so we can see when we get errors. Right, let's try that again. Right, so we got it working successfully. And here we go, we've got an S, right, so I've done something wrong. What I did wrong is I forgot to do origin 0x7c00. Going back to that 0x7c00 thing, the BIOS loads our program into this address, so therefore if we want to have the offset of our value calculated correctly, we need to put this origin here, or else it would have calculated the offset from 0, therefore giving us the wrong memory address when we do this. So now let's compile and it will work. Ta-da! Now we get t, which is what we were looking for. Now let's make a function to actually print this entire string. So we'll keep this here. Right, so we want dot loop. Right, but what we want to do is cmp, so it's a conditional. If the value at bx and 0, if the value is equal to, so jump if equal, we want to call exit. We want to jump if equal to 0 to dot exit. And then if we don't jump, we want to print the value to the screen, increment bx, so we want to add 1 to the address that we're pointing at, and then jump back to dot loop. Let's try that out and see if it works. I forgot to put the colons for the labels. Alright, we had to specify that we were comparing the value of bx against a byte, so there we go. Now we can run it and potentially we will get the string. This is a test string. Yes, we got it to work. There's a few errors along the way, but we got there in the end. So we have a function. Let's just go over it and see what we've done. So we move the magic number into AH. Then we enter this loop. If the value at bx is equal to 0, then we jump to exit. We return, and that's why we have that 0 there. But if it's not equal to 0, then we move the value of bx into the low part of the A register, call the interrupt, so the BIOS prints that value, increment bx, and then jump back to here so we can do it all over again. Pretty simple. Alright, that's all we have for part 2. In the next part, we'll be loading more to memory so that we have more than 512 bytes to work with. But until then, thanks for watching, and I'll see you next time.